A very warm welcome, students. Class 8 Science, Unit 1, Man and Machine. इस यूनिट में हम कवर करेंगे कुछ ऐसे कॉन्सेप्ट्स जैसे एनर्जी, मूवमेंट, साइंटिफिक इनोवेशन. फर्स्ट ऑफ ऑल, एज द नेम ऑफ द चैप्टर सजेस्ट्स, मशीन. मशीन क्या है? व्हाट इज अ मशीन? मशीन एक ऐसी डिवाइस है जो हमें हमारा काम आसान करके बताती है, कम इनपुट में ज़्यादा आउटपुट देती है. So machine is a device which makes our work easier and improves our efficiency. Machine is a device that augments or replaces human effort, modifying and transmitting mechanical energy in a useful form. Meaning, मशीन एक ऐसी डिवाइस है जो हमारे लिए काम आसान करती है, हमारे द्वारा लगाए गए फोर्स को कन्वीनियंट डायरेक्शन में मूव करके हमारी एफिशिएंसी बढ़ाती है. अगर हम मशीन से काम नहीं लेते तो हमारा काम मुश्किल हो जाता है. बट जब हमने मशीनों को अपने काम के लिए इस्तेमाल किया तो हमारे काम करने की कैपेसिटी और हमारी आउटपुट दोनों बढ़ गए. पर्पस. हर मशीन का एक पर्पस होता है. एवरी मशीन हैज इट्स पर्पस. जैसे दिस स्टाइलस, इसका पर्पस है स्मार्ट बोर्ड पे मार्किंग करना और स्मार्ट बोर्ड को ऑपरेट करना. एक पेन का पर्पस होता है लिखना. एक वाटर पंप का पर्पस होता है पानी को नीचे की हाइट से ऊपर की हाइट तक ले जाना. सो एवरी मशीन हैज अ पर्पस. वट एवर वी आर यूजिंग मशीन्स, every machine has a unique purpose. Second, work easier. Machine help us to do more work efficiently using less energy and less time. Third, ancient origin. The machines that we are using today are highly developed and technologically advanced. लेकिन क्या machines शुरू से ऐसी थी? नहीं. शुरू में thousands of years before, the man who were living in the jungles and caves, he used very simple tools to make his life easier and his survival possible. उस टाइम पे अपने काम आसान करने के लिए और अपने सर्वाइवल के लिए जो टूल्स यूज करते थे वो भी मशीन्स ही थे. बट दोज वर सिंपल मशीन्स. और जो मशीन्स हम आज यूज कर रहे हैं दोज आर कॉम्प्लेक्स एंड टेक्नोलॉजिकली एडवांस्ड मशीन्स. एवरी मशीन यूजेस एनर्जी. चाहे वो सिंपल मशीन हो या कॉम्प्लेक्स मशीन हो, उसको ऑपरेट करने के लिए, उससे काम लेने के लिए हमें उसे एनर्जी देनी होगी. अब एनर्जी की बहुत सारी फॉर्म्स होती हैं, जैसे हीट, लाइट, मोशन, इलेक्ट्रिकल, केमिकल, ग्रेविटेशनल, न्यूक्लियर, साउंड, मैग्नेटिक एंड मैनी मोर. बट in general purpose, we are using only energy due to motion, that is called kinetic energy, and energy due to position, that is called potential energy. What is potential energy? Potential energy is the energy possessed by an object due to its position. अगर हम किसी ऑब्जेक्ट की पोजीशन को चेंज कर देंगे, फॉर एग्जांपल हमने इस ऑब्जेक्ट को नीचे से उठा के यहाँ से उठा के यहाँ रख दिया तो इसकी पोजीशन चेंज हो गई, तो इसकी पोटेंशियल एनर्जी में भी चेंज हो जाएगा. पोटेंशियल एनर्जी मीन्स द एनर्जी ऑफ एन ऑब्जेक्ट, दैट इज द एनर्जी पोजेस्ड बाय एन ऑब्जेक्ट ड्यू टू इट्स पोजिशन. अगर हमने किसी ऑब्जेक्ट को नीचे से उठा के ऊपर रख दिया तो उसकी पोटेंशियल एनर्जी बढ़ जाती है. दैट मीन्स ये क्या हुआ, जो हमने उसको नीचे से ऊपर उठा के रखने में जो अपनी एनर्जी यूज की वो एनर्जी इस ऑब्जेक्ट में स्टोर हो गई. अब अगर हम इस ऑब्जेक्ट को छोड़ देंगे, यहां से ड्रॉप कर देंगे, तो ये वापस अपने आप वहीं पहुंचेगा जहां से इसे उठाया गया था. दैट मीन्स द एनर्जी जो इसे उठाने में हमने लगाई वो इसके अंदर स्टोर हो गई और उसी एनर्जी का इस्तेमाल करके ये ऑब्जेक्ट अपने आप वापस उसी जगह पर आ गया. तो दैट इज पोटेंशियल एनर्जी. It is stored energy due to the position or state, and the formula for potential energy is mass into gravity into height. Gravity is the pull of the earth which the earth exerts on all objects and attracts all objects towards itself. जो अर्थ किस हर ऑब्जेक्ट पे ग्रेविटेशनल पुल लगा के उसे अपनी तरफ अट्रैक्ट करती है, दैट इज नोन एज ग्रेविटेशनल पुल, एंड ड्यू टू दैट दिस ग्रेविटी इज incurred. Mass means the quantity of matter content in an object, and height is from where the object is picked and from where the object is placed. So this difference in positions is the height. So mass into gravity into height, अगर हम इन तीनों को मल्टीप्लाई करेंगे तो हमें उसके अंदर की पोटेंशियल एनर्जी मिल जाएगी. एंड दिस इज नॉट ट्रांसफरेबल डायरेक्टली. अगर हम ये सोचें कि इस ऑब्जेक्ट की पोटेंशियल एनर्जी हम किसी और ऑब्जेक्ट में ट्रांसफर कर दें, डायरेक्टली ट्रांसफर नहीं होती. पोटेंशियल एनर्जी इज ऑलवेज ट्रांसफॉर्म्ड इनटू काइनेटिक एनर्जी. दैट आई विल टेल यू लेटर. इट डिपेंड्स ऑन हाइट एंड मास. Examples: a stretched rubber band, the bow and the arrow that the archer uses. The archer uses his muscular energy to pull the bow. So the energy spent by the archer is stored in the bow, and when the bow is released, that stored energy of the bow gets transferred into the arrow and the arrow flies away. That means the energy spent by the archer gets stored in the bow as potential energy, and when the bow is released, that potential energy is transferred to the arrow as kinetic energy because the arrow is moving, it's flying away. Chemical, gravitational, nuclear, electric, all are forms of potential energy. A cell, a battery is capable of delivering electric and electrical energy to move any circuit, to move any electrical device. So that is also known as potential or stored energy. Any energy that is stored in an object is known as potential energy because that object is capable of transferring that energy for useful work to be done. Now, kinetic energy is the energy possessed by an object due to its motion. Always keep in mind that only the moving object will possess kinetic energy. If the object is not moving, if the object is at rest, it has zero kinetic energy. This is energy due to motion. An object at rest has zero kinetic energy. Why? Because object is not moving, it is not in motion, so it does not have any kinetic energy. It is transferable from one body to another. Suppose I throw a stone and that stone hits a stationary football, a football which is at rest. एक पत्थर फेंका, वो एक रुकी हुई फुटबॉल पे लगा, तो पत्थर रुक जाएगा, फुटबॉल चल पड़ेगी. That means the kinetic energy of the stone is transferred into the football. It depends on speed and mass. जितनी ज़्यादा स्पीड होगी, काइनेटिक एनर्जी भी उतनी ज़्यादा होगी, और भारी ऑब्जेक्ट की काइनेटिक एनर्जी ज़्यादा होगी इन कंपैरिजन टू अ लाइटर ऑब्जेक्ट. एग्जाम्पल्स आर फ्लोइंग वाटर, मूविंग कार, फॉलिंग बुक. एंड द वर्ड काइनेटिक इज डिराइव्ड फ्रॉम अ ग्रीक वर्ड काइनेसिस विच इज नोन एज मोशन. नाउ कम वर्क, पावर एंड एफिशिएंसी. व्हाट इज वर्क? वर्क कब होता है? जब कोई फोर्स किसी ऑब्जेक्ट पर लगे और वो ऑब्जेक्ट फोर्स की डायरेक्शन में मूव हो जाए तो हम कहते हैं वर्क हुआ. सो हाउ डू वी राइट इट? वर्क इज डन व्हेन अ फोर्स एक्ट्स ऑन एन ऑब्जेक्ट एंड द ऑब्जेक्ट मूव्स इन द डायरेक्शन ऑफ फोर्स. और वी कैन सिंपली से a force which produces displacement does work. How do we calculate work? Work is calculated as work is equal to force into displacement. फोर्स इंटू डिस्प्लेसमेंट, कितना फोर्स लगा और उस फोर्स ने कितना डिस्प्लेसमेंट प्रोड्यूस किया, इन दोनों का जो प्रोडक्ट होता है दैट गिव्स अस द अमाउंट ऑफ वर्क, एंड द वर्क इज मेजर्ड इन जूल्स. द सिंबल इज कैपिटल J. Joule is the unit in which the work is measured. Here is written that work is done when a force causes an object to move in the direction of force. That means energy is transferred. Suppose I am moving a cart. Who's spending energy? Me. What is moving? The cart. So my energy, which is spent in moving the cart, is being transferred to the cart as work. Power. Let's suppose there are two workers who are doing the same amount of work, but one worker finishes the work early and the other finishes late. So what do we say? The first worker is powerful than the second. Why? Because he is doing the same amount of work in lesser time. So power is defined as work done per unit time, or we can simply write as power is equal to work done divided by time. If the time is less, the power will be more, and the time is more, then the power will be less. Power is the rate at which the work is done. More work done in less time, that means more power. And the unit in which the power is measured is watt. Symbol is capital W. Next is efficiency. Efficiency means कितनी एनर्जी हमने इनपुट दी मशीन को और मशीन ने कितना आउटपुट दिया. And it is represented as a percentage. The formula is useful work done upon total work done into 100. We can also write it like this: efficiency equals useful work upon total energy into 100. This gives a percentage. Suppose a water pump, take the example of a water pump. A water pump uses 1000 joules of energy in 1 hour, and its work is to pump water from a lower height to the overhead tank. And in transferring the water, the useful work done is 700 joules. So we will find out the efficiency as useful work, that is 700, divided by total energy supplied to the motor, that is 1000 joules, into 100, which gives the efficiency as 70%. That means the water pump is working at 70% efficiency. 70%, what does it mean? It means that out of the total energy received by the pump, it is converting 70% in useful form and wasting the 30%. And 30%, any machine, whether electrical, whether mechanical, no machine has the efficiency of 100%. Some energy is always lost in the surroundings, as heat, as light, as sound. When the motor is working, you hear a sound. That sound is also a form of energy. And the energy supplied to the motor as electrical energy, a part of that energy is being converted into sound. And also you can see that after some time the motor gets heated up. Heat is also a form of energy. And from where does the heat is coming? Some of the current is also getting converted to heat. So when a pump is working, a part of the total energy supplied to the pump is being converted to sound and heat. that is the wastage. Rest is converted into useful work done, so the efficiency of the motor is about 70%. Next, the topic is some simple machines. These 6 are simple machines. Simple machines means almost no moving parts are there. The first one is the lever. Lever is a simple rod which has 2 ends, and it also consists of a fixed point around which the lever can move. Suppose this is a rod, this is the fixed point, a lever can move like this. So at one end there will be some load, at the other end there will be some effort, and the point at which the lever is moving is known as the fixed point or fulcrum. So a load, fulcrum, effort, and a rod, all these are consist in the lever. A rigid bar, that is the rigid bar, a fulcrum, that is the fixed point. These two constitute a lever. And where a lever is applied, at one end there is load and the other end there is effort. So if less load is being used, is being lifted using more effort, then the efficiency is less. And if more load is being lifted by using less force, then the efficiency is more. Example, most common example is the seesaw. Scissors, crowbar, all are examples of lever. Next is the wheel and axle. Wheel, like the wheels of a vehicle, and those wheels are attached at their center through a rigid support around which the wheel moves. That is known as axle. So a wheel and axle, they both constitute together as a pair known as wheel and axle. A wheel attached to a rigid bar, force on the wheel rotates the axle, magnifying the force, and the oldest known, the toy cart in Mesopotamia. Anything that is moving on wheels will have an axle attached to the wheels. And by using this, we can push heavy loads with minimum efforts. Inclined plane, in simply it is also known as a ramp. Suppose from the ground we have to move to a platform that is slightly higher. So either there will be stairs or simply a ramp, and we can move heavy load using that ramp to the top of the platform. Same work done over a longer distance with less force, and it was primarily used for the construction of monuments in the early times. Next is the wedge. Wedge is a solid object which has two inclined planes together, like this. One inclined plane this, one inclined plane this, and together they meet at a point. This is a wedge. A double inclined plane that moves to push objects apart. The axe used to cut the trees is the simplest example of a wedge. We strike the tree with the axe, the point of the axe, the edge of the axe penetrates into the tree, and as the axe is pushed further, the inclined planes pull the tree apart and the tree is cut. The object is slashed. Next is the screw. Screw is a kind of curved inclined plane. A shaft with an inclined groove An inclined plane rotated on a bar that constitutes a screw. Rotating it converts rotational force to linear force. Whenever we push a bolt like this, the bolt moves forward. That means we are applying rotatory force. But that rotatory force is being converted into the linear movement of the screw. We rotate it like this and the screw moves further. So rotating force is converted into linear force so that the screw moves apart in a support. Next is a pulley. A pulley is a very simple machine which is used to change the direction of the force so that lifting of an object becomes easier. Most commonly, we have seen mostly it is used in wells to lift water, buckets of water from inside the well to the top. If we lift the bucket using our hands, then the weight of our hands will be added to the load and we'll have to apply more force to lift the bucket. But if we pull the rope over a pulley and we pull downwards, then the weight of our hands is added to the effort. And the lifting of the bucket through the pulley becomes easier. So pulley changes the direction of applied force in a convenient way so that lifting an object becomes easier. It is a grooved wheel with rope or a cable, reduces force needed over a long distance. Now, pressure, force and moments. What is pressure? But to understand pressure, first you have to understand what is thrust. Thrust is represented by capital T. Any force that is applied on a surface in a perpendicular direction, not inclined, but perpendicular, normal to the surface. Any force which is acting normal to the surface is known as thrust. And the area on which that thrust is acting makes the pressure. So pressure is what? Thrust per unit area is known as pressure. Pressure is thrust divided upon area. This is a marker. One end is pointed, one end is flat. I push this marker between my palms and apply force. I am applying equal force on these two ends of the marker. One end, remember, one end, that is the pointed end, has less area and the other end has more area. And on both the areas, same force is being applied. Now, if you can see, on the part on my palm where the pointed end of the marker was kept, here it has made a small groove like this. But on this end where the flat end was put, no such groove is there. So this demonstrates that if the same force is acting on a small area, it will produce more pressure, and if the same force is applied on a larger area, it will produce less pressure. That is why cutting of fruits and vegetables using a blunt knife requires more force, and if we use a sharp knife, then the same fruit will be cut easily using a less force, because a sharper knife edge has a very small area and a blunt knife edge is having more area. More area, less pressure, less area, more pressure. Force applied perpendicular to a surface per unit area, larger area, that is less pressure. A pin exerts more pressure than the hammer. Why camels are capable of walking easily on sand as compared to a horse? The reason is being same pressure. The area of the feet of a camel is very large So the weight of the camel produces less pressure on the sand, so its feet does not sink in the sand. But if a horse tries to move on the sand, the weight of the horse produce more pressure on the sand because the area of the feet of the horse is very less as compared to the camel. So more pressure is created and the feet of the horse sink into the sand and it is not able to walk on sand. That's why camel is known as the ship of the desert. What is moment? Suppose I'm holding this marker like this. At this end, the marker is fixed, this end is free. If I apply some force here, the marker rotates. So I'm applying a force and the marker is rotating. So this turning effect of force is called moment of force, and it is measured by the product of force and the distance of the force from the fixed point about which this object is rotating. So this distance multiplied by the force applied here is called the moment, that is F into D, force into distance. A lever pivots around a fixed fulcrum. We put force on the lever and the lever rotates. So it is giving a moment to the force. When equal forces or equal weights are put at both ends, just like in a beam balance while purchasing some fruits or vegetables, it is balanced. That means the mass of the fruits and the mass kept in the pan, both are same. At that point, it is balanced. So how it is balanced? Because anti-clockwise moments and clockwise moments both are equal. I am rotating this and this force is moving it in a anti-clockwise direction and this force is moving it in a clockwise direction. When both forces are equal, then the total anti-clockwise moments and total clockwise moments are equal and this lever is balanced. So this is the condition of balance. For machines to work, energy is needed and that energy is provided from fuels. Fuels are the energy sources. So fuel is any substance containing potential energy that can be extracted to provide energy for the machine. Most commonly used fuel for our appliances, electricity, then petrol, fuel, diesel, again fuel, coal, kerosene, wood. So fuel is something that provides energy in any form, preferably electrical, heat, and that energy derived from the fuel is used by the machine to give the desired output. जो भी हम फ्यूल मशीन में डालेंगे उस फ्यूल की जो पोटेंशियल एनर्जी है वो मशीन रिक्वायर्ड फॉर्म ऑफ एनर्जी में हमें डिलीवर करेगी. So fuel is a substance that provides energy for a machine to work. Car is a machine. Most common fuel, petrol, diesel and CNG. There are some characteristics of a good fuel. Not every fuel is good. हर फ्यूल अच्छा नहीं होता. हाइड्रोजन गैस एक अच्छे फ्यूल हो सकती है लेकिन वो अभी अच्छी है नहीं because it has some constraints, some limitations. So a good fuel should burn easily in air. हवा में अच्छे से बर्न होना चाहिए. उसका environmental impact low होना चाहिए. That means it should be eco-friendly. It should create very less pollution. It should be cheap and affordable. A very costly fuel is not a good fuel. Another, it should release high energy. That means if we burn a fuel, it should provide us with considerable energy. So its value is justified. It should be available in the market. दैट मीन्स इट शुड बी ईजिली एक्सेसिबल। अगर किसी फ्यूल को यूज करने से सेहत पर नुकसान नहीं होता, दैट मीन्स इट इज सेफ। तो इट शुड बी नॉन टॉक्सिक, नॉन पॉइजनस एंड सेफ, and should be suitable for storage. That means if we store it or if we transport it, it should be safe in both the cases. So all these are the characteristics of a good fuel. Now in this chapter, there are some questions which are factual, conceptual, and debatable that would be discussed in the class. Thank you.